and welcome to another video from In3D Software. Today we're going to look at imos IX 2019 and how it can be used to create a point of sale display unit. I'll just bring up this photo here. So this is a piece of furniture that has been previously designed, and we said that we would create this again in a step-by-step video. We may make some changes along the way, but this is the general overall design concept. So if we open up imos, first thing we want to do is design one of the individual elements of the actual piece of furniture. We'll use Article Designer, and we'll create this from a top view, because later on we want to be able to change the overall outline of that particular product. I'll give it my height. In this case, I want this to be 1.2 meters high with a width of 900 and a depth of 350. These sizes don't need to be hard and fast. We can change these at any point if need be. We'll add in some parts. We can take the door off. And we'll add in 3 shelves. These are fixed shelves, but we could easily make them adjustable as well if need be. We need to change some of the individual parts to be more suited. So for example, I want a panel back rather than a grooved in back. We can see that it's grooved in by looking at this from the top. I'll change the back here by dropping down, choosing my Type 2 back, which is a panel. And I may give this an inset of 20 millimeters, just to bring it in from the back edge a little bit. My side panels are stating that they are edged on all 4 edges, so I'll just edge it on my leading front edge here. I'll create the part. And I'm going to add some legs to my base. Okay, let's visualize. This looks okay as my starting point, so I'll save this. With the article in place, we can now make some changes to the actual finish of the product. So what I'll do here is use an order related variable. If we come into the basic data, we can change the basic data for the carcass. And we'll choose, I think, N. Egger rustic oak. This looks nice. The next thing to do is to go down in our visualization level, go into a plan view and switch to a wireframe. We can now turn on article mode, and we can copy the product using the AutoCAD command. I'll array this 4 times in this direction with a spacing of 900 millimeters, the width of the article. I'll also copy it again and then rotate these. Now they are back to back. I can increase or decrease this gap as much as I like. For now, I'll leave it as it is. The next step is to change the overall outline of the products. We can do this quite simply by selecting a product, go to the Modify tab, and choose this symbol here to modify the contour. This allows me to then pick the rectangle and change the overall shape. This can be done for all of the others to create an interesting break front. I'll do this now. The next step is to create some more products that can sit on the end. Now, we might want to taper these so that they can become facing inwards as well. I'll use AutoCAD to create some construction line geometry that will allow me to then snap the part to where it needs to be. I can offset the geometry, the main depth of the unit. And now when I add in an article from the article center, now rotate these. I'll now alter the outline as before. Using the construction geometry as a reference. Now I have my funny shaped units arranged and lining up perfectly. I'll change the insertion height of these units as well to fall in line with the outside ones that have a height of 150 millimeters for the leg. I can do this by selecting them and then changing the properties for the Z insertion point. I can also alter the number and position of shelves if need be. You can see the article designer has now taken the outline geometry shape of the unit, and it is just a case of changing the number of shelves. With the design of the cabinets now complete, I can now add a worktop. I'll select all of the items, go to the methods, and add work surface. This will now have one complete work surface covering all of the items. I'll confirm with a tick. This needs to be split, so the next stage is to isolate this item. Go into a wireframe view from above and split this worktop. I can do this by selecting the item, finding the part within the tree, and then choose a splitting principle. I have numerous options, but I'll use point to point. I can then decide where I want to split. With the worktop now split, I can add fittings if required to make it easy to connect these on site. A white plinth would match the worktop. This is the next step. The same process applies. I'll select the items and then apply a base plinth. Here I can choose what type of plinth I want to use. I'll choose a front, left, right and back with a 20mm inset. But I want this to be all the way around. I can save a new principle and then apply this to all of the edges. Here we can see that the plinth is going to be mitered, which is what we want. Technical drawings can now be produced quite quickly and easily using the Drawing Views tab. I'll first create a plan view. And an elevation view generated from the plan view. This process can then be repeated. The 2D CAD blocks created will update as soon as the model is changed. Sections can also be created. Here, I'll refresh the view and alter the settings. Ensuring that all of the items are captured within the section. I can also refresh the view to include coloration. The next step is to produce a layout. With the technical drawing now complete, it's now time to move on to manufacture. imos has the ability to generate CNC programs for a number of different types and manufacturers of machines. If we move to the model, we can save the order and generate CNC data. imos will save the order and then open the automatic program generator. At this point, we then have the option to choose a workflow or allow imos to automatically filter parts to the workflow that best suits the features that are being requested. In this case, we will manufacture everything on a 5-axis machine that has the ability to edge band as well. A workflow could be set up that would be suited for nesting or a combination of different machines. Down on the bottom bar, we see the progress of all of the CNC programs being generated. The CNC program has been completed. We'll open up some of the programs to have a look at the results. This piece, the worktop, will require edge banding all the way around on the CNC after it has been formatted. This piece, the side panel, has more than one edge with an angle application to the leading and back edge. Let's look for program 1119 and 1057. Here we have Biesse, the software used for Biesse CNC machines. I'll start a new program, and we can see we have our CNC machine here, an edge banding 5-axis machine. I can import a program, and here in our folder for the particular material that we were using are all of the programs. We'll look for 1057. Here we have a number of different types of CNC machinings, such as angle drills, top face drilling, and edge treatments. We can run a quick simulation here. All machining and tooling is passed directly from imos and can be configured within imos so that the machining is directly applied to the programming. Now let's look for the top. again we can simulate the results. Because imos is using a condition-based logic, we can apply filters to parts and certain machinings so that they will always be applied dependent upon the type of machining required. This means that the correct tooling, lead in, lead out, speeding, diameter, and feed rate can all be passed directly to the program from imos, with little application being needed within B-Suite. With the program now complete, we may want to make a change, perhaps add in some further machining. This is very easy to do within imos, and it allows it to be documented via drawings, the 3D model, and any reports. Let's head back over to imos and make a change. If I go into a top view, I can then switch to a wireframe view, and here you can see the void that was left earlier. Perhaps I want some sort of cable access for a display that's going to be put on top of the worktop. In that case, I'd need some sort of pocket or access cut. I can do this easily by using a circle. Once drawing the circle, I can use AutoCAD commands to snap it accurately to the diameter that I need, and then position it exactly where I want. I can make copies, and then select the part and apply machining. Here I'm going to choose circle as pocket and choose the two circles that I drew. This is now passed the machining directly into the part. I can specify that this is a through hole and click tick. I will now regenerate just this one part. This can be done by right-clicking on the name and then click Generate CNC Data. The option to choose which workflow is also presented, and I'll click Delete and Start. The program has been generated, so let's switch back over to this software. I'll re-import display part 1119. Here we can see it's been generated. Here we can see the part has now got the additional machining added. So this concludes the tutorial for our display unit. If you have any questions, please get in touch. Thanks for watching.